Okay, so first of all, I'm still not done with the food, but I can start the stream. So it's fine. It's fine. And as usual, the very first thing, very first thing, we do be looking at the video from last time. Oh, yeah. Last time I forgot this text on the screen for a while. That's unfortunate. And I had it on during the zoom out. No. Anyway, well, it's there now. It's gonna be there forever. Aye, aye, aye. Okay, interesting. I still have some browser stuff open that I shouldn't have in the background. You might notice that I have Godot open in the background, but this is me trying to debug the friction stuff and how it should work. Just trying to just go in blind and do it is quite difficult. So I thought that I would do it with visuals. And then just translate the logic. Well, I mean, right now I think I have the correct logic. Oh. There we go. It has been full screened. And it's going back. And the text kind of does grief that, though. Whatever. Anyway. I believe you have the current correct logic. Let me... It's just... Why have... I've just been looking at Roadrunners. Cool. Anyway. This is my debug city right here. And, yeah, I meant to reparent this. Let's fix that. Anyway. So right here, I basically have a, I'm taking the velocity. Also, let me hide the first friction thing. It's in the way. So the green line is the velocity. The blue line is the movement direction that we want to move in. It's a unit vector in reality, but here is some arbitrary length. I don't care about that. And this movement vector rotating means that the friction, which is this light blue line, I guess, or cyan, whatever, the friction changes based on the angle of the movement, like relative to the velocity, right? And right now, I made it so... Well, what I'm trying to do, and what I think I have done, is that I almost choked on my food, don't worry about that. Anyway, I'm taking the component of the velocity that's pointing away from the movement, and well, I'm also multiplying it by -1. Let me actually not do that. Let me not do that either. Actually, might have to do that. Yeah. So I'm taking the component of the velocity that's pointing away from our movement vector, right? So it's perpendicular to it. And, well, right now I'm multiplying it by 1 just to visualize it, right? And we can see that it does line up, right? When this is a 90-degree angle, the component of the velocity that's pointing away from our movement vector is the velocity vector, right? So that works. And then if we're pointing, like if we're pointing away, then yeah. If we're pointing to the opposite direction, then the component pointing like perpendicular will be 0. And if we're pointing to the same direction as the velocity, then the component pointing perpendicular will also be 0, right? So this makes sense. I can isolate this component, and that's what I want. And I can now turn these the other way around, where I'm taking the component of the velocity that's pointing towards movement. Or like, yeah, it's either towards or away from it. I still need to figure out what to do when the movement is pointing away from the velocity, but like the only cases that I'm really worried about are the cases where we're in this like half sphere, I guess hemisphere, where the angle is not greater than 90 degrees between these vectors. And yeah, here you can see, yeah, we're taking the component of the vector that's pointing towards movement. Wow. And I guess here it would be the same if I multiplied it by -1, I guess. Then it would be, yeah, what? Me. I'll figure it out. Yep. At least I believe this is mapped correctly. It looks correct. And then if I take both components, then we just have the velocity, right? The idea is that I might have something like, which one was which? So this is the one that's pointing away. So this is the one that we want to treat more harshly. So let's put like 0.5 here. And then here, let's put like 0.125. So the friction force would look something like this. These are like bad example numbers, but whatever. Basically, or wait, is this the wrong way? This is the wrong way around. I guess the friction is supposed to be greater when we're pointing away, not the other way around. Let's do this. And all these shenanigans that I'm doing here, I do want to turn it into like proper math. So I gotta figure out how this actually works. And yeah, this is incorrect right now. I think. Where is it? Let me think. Bum. I wish this animation skipped this half of the sphere. I gotta make it do that at some point. Actually, this is correct. I think, no, it's not, because now it's trying to make it. Okay. Let me reparent these things. Let me make a duplicate of this. I am doing some shenanigans with these vectors. Then we have two copies of the vector. One from the tip of the velocity. So this is where it wants to, like, move velocity, basically. And the other is from the origin. And right now you can see that it's trying to make velocity greater, which is not what we want. But, we'll figure that out. Oh yeah, it's supposed to be times -1 here. That's why it's incorrect. Yeah. Yeah, no, this is correct. It's trying to reduce the velocity, and then if we're like, if our wish direction is pointing this way, let's disable the animation. If our wish direction is pointing here, then our velocity will be on this axis slowed down less, so we don't go like down here as much. But it will be reduced on this direction less than it will be reduced on this direction. Right? It's reduced more here. So effectively the velocity gets like turned into this direction. Or like translated however you want to like word that. Right? It kind of just does it. But why do we turn back towards here when we're here? Well, it also makes sense because there's no component of the velocity that's going to the direction that we're trying to go. Right? Because we're perpendicular. So we just reduce the velocity by a lot. And the same as here, we don't go to the side because there's no component that's perpendicular, it's all the same direction. So we just reduce less. But in the middle, at a 45-degree angle, approximately, reduce the one component more than the other. That results in this. And the last friction stuff that I had, let me reprint that. Was this line here? I guess magenta. And it would never like point to the sides. It would just either have greater friction force or lessened friction force. Right? And that's not really ideal. It kind of worked, but it did result in a feeling that the player character was like slipping or like we were on ice. If your velocity was great enough, then it felt like you're on ice, which is not good. But I think this is what I want. Like, this is the friction force that I want. It's gonna kind of turn the movement. It's still going to reduce the... It will always reduce the length of it, so we still have friction. But it does it in like a quote-unquote smart way, right? And I'm gonna eat the rest of my food while I think about this a bit. I mean, really what I just have to do is take this logic here, and I mean, first of all, I can strip this down. This just the stuff that I need. And then I need to translate this into math. And like figure out, okay, what is the like least amount of stuff that I need to do this. But I'm gonna eat first, and then I'll continue. And it should be like a few minutes at most. And if you send something in chat, I'll see it. I'm still here. I just thought that I might as well make the animation play while I eat, because why not? For fun. Oh, that's not true. I deleted the wrong section. There we go. Yippee! Mm-mm-mm. Alright. Also, I gotta move my notes stuff. I have Obsidian open there. There's some notes that are not for the stream. I'm gonna move those to my other screen. There we go. Oh, actually, I need to do one more thing. There we go. Anyway. Bum 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 bum. Let me first look at this logic and see if I can simplify it somehow. So basically, I want to create something where the logic is as simple as possible, but it will yield in the same thing as friction 2. I think I'll just make friction 3 also be a child here. And I will just write some other line here. If I do this, for example, then... Where is it? What color do we have for you? You're this color? Use something else. Also hide the original friction. Well, this is probably just too short. Yeah. Now it's visible here. This is the friction 3. So I gotta figure out the maths to make friction 2, but better. So I don't really want to... Also, this dot thing is not needed. Alright, first. Firsty. Also, one thing that I meant to mention is that for some reason the flatback version of OBS just started working. Like, okay, there's probably some update. But I'm not gonna get rid of the non-flatback version just yet, just in case it breaks again. But yep. Oh. Nice. Oh yeah, my current notes about the movement design are a bit disorganized. I've been thinking about the friction stuff. So, yeah. It's a bit of a mess. Right. But the moment I finish friction, I'm gonna come into these notes and just clean it up. What did I write in brain dump about this? Oh yeah, yeah. What I wrote was basically to do the Godot thing that I was doing. And just visualize the vectors. And yeah, it is different. And I think it's more correct. Anyway. Yeah, we have the relative angle between the movement and the velocity. Do I really have to get the angle of these? Let me hide the friction stuff for now. I'm gonna start by making a velocity rotated. Because this is what I use for getting the components that are pointing towards and away from the movement. It's very interesting. It's just like ahead by a bit. I haven't looked at this vector in a while, but it works. It works. It's just a bit strange. it's always the same length as this, but it's just turned, I guess, in a 45-degree. Yeah, that actually makes sense. Because if we're at a 45-degree angle to the movement, then what it means is that one component is this direction and one component is the other. I swear it makes sense. Yeah, well, I mean, the math works out, so it's fine. It works out in the end. I don't think I can get away with not doing this. Or, I mean, I at least need this. So I'm thinking, so I'm gonna have another velocity rotated here. And what I will do is figure out a better way to rotate it. I think that makes sense. And if there's something dumb like this where ah oh yeah. Then I would get like the sine and cosine of this or something. I think I can just get the angles, honestly. Mm-hmm. This is the illustration, by the way. Okay, so I really... Okay. So I'm just doing a tan 2 here. Okay. We do a tan 2. A tan 2. I mean, this might be fine, honestly. And then the dot rotated is just... This is the relative angle. Alright, we can have that. You can tell that I want to type Rust when I'm typing let instead of R. Anyway, relative angle. And then we want to construct a vector from this. We use sin and cos. I think I just do think this should work, right? Oh, it's an underscore there. Underscore. Right? It's not quite that. That's interesting to me. I thought this is how you rotate a vector. Apparently not. Apparently not. Oh yeah, well, duh, 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 duh. The other one is always 0 here. Just do this and then multiply it by the length. Almost. It's like reversed now. It is basically this, right? Either I need have this be negative, Or do I need to switch to the sign in the cos? I think needs to be negative. So turn these around. Not quite, not quite. They're moving the same direction, but they're 90 degrees apart. Let me put this here and make it always on top. Okay, now they're... Okay. Maybe it was correct the first time around. Now they're the same, probably. Let's just hide velocity rotated. If I hide both, then it disappears. If I show one, then they're the same. Okay. Gooda. Gooda. So basically, I just have to get the relative angle and then construct a vector based on that. And then I have that. Mm. And then, I mean, also I can just multiply this by -1. So we already have, like, this is kind of the friction force already. Oh wait, hold on. Wait, it is, it is. It's a bit strange to see it like that. Oh, incorrect. I hid the friction. Funny business. This needs to be together one still. Like fucking up the math right now. But it's fine. Okay, let's keep the working one here. I think this is the way that I had it before. Gotta wait for it to go the same way. And what I thought about doing was like committing the current state, and then I just didn't do it. Hello? And I think this is correct. Anyway, let's commit the current states. We have playground. A lot of stuff. Here we go. Now we have this state, and now I can modify this and not really be worried. But I'll keep this the same, just so it's easier to handle. Relative velocity. But now I'm thinking, is there a way to kind of skip a lot of this? Because we're getting the relative angle. And we're constructing a vector based on that angle. And then we are taking that and multiplying it by some constants and rotating it back by the movement angle. So it's like this here is the same as this. I don't know if there's some way to do this otherwise. Let me think. I think we do have to rotate the velocity, because that's how we know how much of it is pointing to either direction, like either towards us or away from us. I could just translate this to math and then feed it to the TI calculator, or try to do it myself. True, true. Mathy math time. I can't collapse you to the half of the screen because you're a special child. And you don't want to do it either now. Here we go. Okay. Let's first confirm that this is actually what we want, though. Where's the expand everything button? It's actually just hidden. Thank you, Godot, for scaling incorrectly. Holy. Take friction, and then we make it relative to velocity. Then we go to the script and make both 1. Then it's just the velocity. And well, it's pointing there. That makes sense. We make the other component 0. Actually, put it to the origin again. It's pointing away. I don't really want to do that. So let me not point away. Okay, so this is the component that's pointing away from the movement. Yeah, there's a 90-degree angle here. I can clearly see that. I can multiply that by -1. Keep it the same. Yep. I think that's correct. Then if I turn this around, and this is the component into the direction of the movement. Yep. Seems right. Seems correct. Seems correct. I think I'll just copy this code. I don't think we have GTScript highlighting here. We don't. Let's do Swift. Get some colors. We don't need that. We don't need that. We don't need that either. This is irrelevant. And these are irrelevant. I should have named these better, but that's fine. And move that there. And then I'm gonna put this here. That's good. not doing this, I don't think. Yeah. Mm-hmm. This in reality is this. I could do it like in here as well, but it's fine. Hmm. I guess we also have angle too. See if this outputs 0. It does not. Okay, now it's basically 0. There's like some error terms, but that's a floating point for you. Okay, so we want to get the angle between vectors. So I know that's not the one. I don't know if I know this mathy math thing right here to get the angle between these two. But this is what I want. I just want this. And this also is the signed angle, which is good. At least I think so. Yeah. Yeah. Oh. Actually, I'm doing this right. No, I'm not doing that. I'm doing angle minus angle, not thing minus thing dot angle. Yeah. Yeah. Yep. Hmm. I think no. I don't need this. Let's go here. Does Swift use this for comments? It does. Okay. So this is pseudocode, but that's fine. I think this is gonna stay the same. Oof. The only thing that I don't like is that we're doing this rotation thing here. But I think we need it. There might be some trigonometry that would be possible to make this simpler. I don't know though. Well, yeah, but this is the code part. That's fine. I'm gonna figure out the math side now. Bit a bit bigger. That's why not. I don't need that much screen space. Next thing. Grand memo would initiate. Okay, so what do I want to do here? First of all, And these are all vectors, but I don't feel like doing the vector thing all the time, so I will not. Oh wait, these are old inputs? Well, not exactly. Mm-hmm. Yeah. So this is what we have. The lenient friction is for the component that's going the same way as movement. And the aggressive is for the one that's going away from it. If these four things, and then what do we call this? B. Why not? Well, actually, I'll call it M. Why not? I feel like M is a very not used letter. So first, we want to get the relative angle. And one way to do this is to just get the angle, and then we'll do this. I might simplify this, but we'll see. Oh yeah, and this is the Atan is a it's arctan. I don't think arctan 2 is a function that we have in math. Hmm. Okay, let's do normal arctan. Actually, I'm interested. Do that minus, then we need this, but with velocity. There we go. And we're pointing the same direction. It's basically the same, aside from any floating point errors. But when we point away, what's gonna happen? Oh, it's still the same. Interesting. Oh, now it's different. Oh, no, even the other one is different. Interesting. Now it's like 0 again. Huh. What does it look like now? Let me change the color for velocity rotated to. Hmm. Okay, yeah, that's just incorrect. Like, it's the same here, right? But then, when we go far enough, then it just fucking flips the other direction. But we'll pretend like this is A10 for now. Or I mean, I just do the math, and if it doesn't work out, it doesn't work out. That's fine. And let me reference this. Is take the movement, so which direction? And we want to do y divided by x. Make it neat. So we take the arctangent, and really this should no say arctan, it should say this. So we take the arctan, and then from that we subtract this one, but it's supposed to be velocity instead. Nice. I have this. And so this is the relative angle. That is the relative angle. There we go. Mm. We have this. And then what we want to do. Hold on, let me click on something. I can't. Damn. I got a spam bot blocked by auto mode. I was like, damn, is there a button that I can use to report this? There wasn't. And what we do here. Also, if I do. No, I can't do that. I think I'll just separate them by a comma. Like this. Wait, was it? It was cost first. I love typing like this. If I wanted to do this fast, I wouldn't do this left and right here. And actually I do want to show this. It just makes it a bit neater. You can see that the other, well, let me make it bigger. Well, here it's even more clear. The other one kind of just does does the braces correctly for ellipses, and the other one doesn't. Not ellipses, but anyway, so this is more correct. Most of the time it's not visible, but sometimes it is. Okay, so we do cosine, and yeah, we just take the relative angle. Okay, so we take alpha. I don't actually even need the braces here. I can just say cos alpha. And I can do this. Now we have the relative velocity. And then. No, not the relative velocity, we have the rotated velocity. And one component is the direction that we're trying to go, and one component is parallel to that. Not parallel, perpendicular. I don't know which one is which, it doesn't really matter. But yeah, one component is one, the other is the other one. What am I even saying? Ay. Yeah, I don't know if there's a way to simplify this thing, get alpha in a different way. Maybe. Anyway, friction is just this. Okay, well, take VR, we multiply it by a vector. Star friction shits. Yeah, so this is the rotated friction force, and now we need to rotate it back. And how do we rotate it back? I don't think I've done any rotation. Oh, I just have to do this, I guess. Again. Oh. Yeah, I might see something that's going on here. Actually, what am I rotating it by here? I'm rotating it by the movement angle. Let's do this as beta. Whatever. Actually, I kind of want to do... Nah, I'll do beta. It's whatever. And well, movement angle equals wish direction angle. Look at this, seems correct. Hmm. Uh, the thing is, the thing is, this wish direction should be a normalized vector. So I shouldn't really need to do this. If I have a normalized vector, I take the arctangent, and then I do this. I think I just get the same vector, right? So right now, m is equal to w. I think. But I'm not done here yet. I need to do... Do I just take the length? I guess I do. We take... No. This is a bit awkward, whatever. I think there's definitely gonna be some optimizations possible here. You're having two fucking... I don't even know what to call them. Like these fucking little numbers down here. Sub indices? I don't think that... Subscripts? Having two subscripts like this is kind of weird. Hold on, so this is velocity rotated times that. And taking... Hold on. This is that... I wish to collapse this section. There we go. Velocity rotated. Ooh, this is also multiplied by the speed to the length of the velocity. I'm kind of doing this in the wrong position. Yeah, this is not supposed to be here. This is wrong. I was doing these in kind of the wrong places. Oh, well, this can be here. Also, this is supposed to be like this. There's two C dots here. I actually don't want the length of the movement vector here at all. And the movement vector length is going to be always going to be 1 because it's a unit vector. So what you want here is the velocity length. I think this is the only place where we use it. This is the only place where we use the speed. Okay, let me review this. MR, rotated friction force. I'm mixing up M with like movement. This is a bad letter to use for this. Anyway. The rotated. What am I doing here? No, I don't need the length here yet. I don't think. Or do I? I do. I think the rotated velocity. I'm saying that the rotated velocity is. Yeah, we get the angle. And the friction to. This is already rotated and scaled. And then we take the rotated and scaled thing and we apply the friction multipliers to it. And then we rotate that. By the movement. Okay. So right now I'm putting this as MR. This is MR. This is MR. Now we need to rotate MR. And here I rotated. Are doing this. Well, velocity rotated. I never multiplied it by the speed actually. Take this. And this actually doesn't matter here because it's just a scalar number. We don't need this here. Like it's just gonna scale the vector up or down. These are the things that are gonna scale as relative. Yeah, because the length of the vector doesn't matter for the angle. It doesn't affect the angle. So we don't care about that there. So now you have the movement rotated. And we want to get the angle of that. That's what we want to do. And I have to do the funny business again. If that. I think we just do this. Right? This should be the friction force. We take the angle of the rotated movement vector. I think this is all I want to do. With the angle of the rotated friction movement shit, we construct a vector, and then we multiply it by the length. Is that correct? Hmm. If it's not entirely correct, actually. It is not. It is not. It is not. It is not. This assumes that the length will always be the same as the velocity, which is not the case. The length should change based on these two variables, so this is incorrect. This orbit also has a length. Yeah, because if I multiplied this by h, I'll... Now this would be the rotated friction force with the length. I hit the angle. I'm thinking that the length of the rotated movement vector... No, it's not going to be just the friction constants taking into account like that. Because it has to change based on the relative angle. It has to change based on the relative angle. How does this work, actually? Well, okay, let's just do it the dumb way, right? So just do this. And then we get the length of it. What P? I'm done with trying to name these anything meaningful. I'm just gonna copy this from here. Oh yeah, MR, my beloved. P. I think that should do it. This should be the correct lorry row. The first part is done. I think. I kind of want to simplify this now, somehow. I don't know how. What I might end up doing is just taking this logic and translating it pretty much one-to-one to the Rust side in the end. And it's gonna have a bunch of unnecessary calculations, but I kind of want to try to think about this. 7 updates. I don't know if there's any reasonable way to make this better. Alright, let's just try substituting everything in and seeing what kind of a monster we have. We have this here. I want to get gamma. Gamma is just this. Let's get P. Actually, I should probably do it the other way around. We start from the top and like go down. So I don't have to like copy paste constantly into the previous. Like, you'll see. V we can't change, or W. Beta we can change. Also, I should probably make a copy of this. Or at least like... There we go. That's the copy, quote unquote. Yeah, so I have this. Boss alpha? You mean boss whatever this is? VR? Do you mean this? Hold on. Let me navigate. And H is also a thing we know. It looked so neat. Now it doesn't. Ooh, this is a bit different now. Because we have MRX and MRY. This is MRX. We need to do the left and the right here. MRX. We do MRY. Syntax, open, close, open, close. I think, no, this is that. MRY. Also, I'm not sure if I'm gonna benefit from this, but this is partly just for fun, like figuring out what this monstrosity will look like in the end. I probably should have done brace for the cousin, but 10 sin. Oh, I didn't need to modify that. Well, that's a bit scuffed, but whatever. Mm-hmm. That's fine, I guess. It's a bit unnecessary, but I'll do it, I'll do it. Where's our sin? Here. Open, open. Oh yeah, it's 3 on those as well. Okay. He is looking great. I need MRY and MRX again. This is X. We take the Y. I do need that. I think I copied it correctly. We'll see. We'll see. Oh, hold on. This is fucking ridiculous. It's funny though. I will finish this for the bit. Sure. Oh, and we need P here as well. Isn't math clear? Very, very easy to understand. You know? Like, this is our rotated movement vector. We just do this. We just do this. Simply just do this. And then you will apply friction correctly. I gotta... I want to start up a big boy calculator. But I don't know if it has like any license information that I don't want to show. Well, actually, first, I do want to show this. For some reason, in bottles, like having TI and Spire, like fetches this box art. So yeah, I'm definitely, yep. This is what I'm launching, guys. We'll see what happens. Yeah, I don't think there's any license information here, but I do want to be careful. I'm gonna show the screen in a second or two. Yep, I don't see any licensinformation. Also, sorry for the white screen, but it's like, I can't really do anything about that, I don't think. Oh? No. I don't think there's anything I can do. It's white. Can I just paste this in? I can't. I can't just paste it in. Well, some of these things work. Well, there's also a lot that doesn't work. So I gotta remove all the lefts and the rights. Okay, let's just take this into a text editor. Take all the rights. Take away all the rights. So true, so true. Hello? Why is it not finding anything? What? Oh, is it because regex is on? Or this is some, like, special character? I need to escape this. I do need to. Okay. And then I think I have to just remove all the backslashes. Let's try it again. Oh, okay, not complaining about a missing brace somewhere. I'm pretty sure we want to have all the curlies be just these normal ones. What do you mean we're missing a brace? Where? Oh yeah, and I don't know if pan like arctan is like that. How do you do an arctangent here? I guess you just write arctan, right? Yeah. C dots I can replace as well. On frac is not a thing that I would understand. I see. The thing here is a way. If this works, then I'll be surprised. Nope. Not an and, but a division. I still have fractions in here. I have plenty more. Luckily, we have search and replace. Actually, also, this needs to be here. I wonder if it would have been faster to do this by hand. Like, just type it directly into the calculator. So I never removed that. Now it looks like something. Syntax? What do you mean, syntax? Where's the syntax error? Tell me. Oh, probably these. Does it not understand? What are you complaining about? Oh, there's a comma here. Oh, that might be the reason. Let's just do times, whatever. Okay, so now it's like... No. How do I make a vector? It accepts everything else, the fact that it's a vector. But I don't know how I can specify a vector. I don't really want... These are like complex number shits. I don't really want that. I guess... Could have the other part multiplied by this. And have the other part as well. Sin arctan. What do you... If you want to have sin arctan. I wonder why this didn't like get fixed up. I don't know. Take the letter part. Fix it up. It's supposed to be like that. Wait, this is this one? Amazing. I was not expecting that. Uh-huh. Did I do something incorrectly then? Maybe, maybe. That's funny if that's this one. Ay, ay, ay. All this number fuckery just to get one in the end. Damn. Damn, damn, damn. I wonder what it says about that. This doesn't simplify. It kind of just expanded it to something very strange. Can I just tell you to solve this and you will do it? No, it just does the same. Expand. You copy this. It's the same shit. Anyway, this has been a great adventure and I don't know what the fuck I'm doing. What even is this equation though? The absolute value tan -1 times this. Okay. Very interesting. Holy shit. I think what I will do, I will copy the dumb logic. I might get it optimized at some point. I might not. This is like in our math classes, we have not gone over like vector math yet. Why did you close? Oh man, go away. Go away. Thank you. Thank you. Anyway, that was a fun adventure. And this is something else. Ay ay ay. Back to my non-light mode applications. Yeah. Oh yeah. Right now, this is how it works. We're jumping around. We have low friction when running to the direction that we want to go. If we turn, we have higher friction, and it works relatively well. There's still the issue where if I have a lot of speed, I turn, like it does feel like I'm drifting, right? And here, if in the air I try to turn like this, it's like really, really slow. I don't think it should feel like that. It shouldn't feel like the turning is very, very slow. It's just, ugh. Yeah. Yucky. Yucky. Yucky friction. Let me just slowly turn this direction. You can see we're like drifting. We're drifting. And the same kind of happens on the ground. Oi, look at that. That is not what I want. If I'm going to the side, turn like this, our velocity to this side should diminish way faster than that. This is like, and if I'm running, well, it's hard to do. It's hard to show when I go into the void. Let me just get some speed here. Do the same thing while running. So run here, turn, and we just have that slippery movement to the side. No good, no good. That's what I want to fix. And that's why also yeah, I switched this back to printing a new line just so I can like look at the values. Because if I constantly override them, then I can't see what the values were. Oh, let me check something. But yeah, I think with this other logic, it won't feel slippery. And then I can just kind of do that. Do the thing. Football. Yeah, this is... We're doing a bit of Control Z here. This is where I started fucking around, I think. Yeah. Yeah. Yep. But like, this is so simple. It looks so neat. And then this turns into such a monster. Okay. Yeah, don't rotate. I don't think I have anything to rotate a vector with. So I'm gonna make a quick helper function. A quick helper function. Mm-hmm. Oh, forget, I'll take it like this. We have that. And then what else do we need to take? We need to take the angle. Right now, if I say this, then it's gonna give me an error because this doesn't return anything. That's plus. I keep doing the wrong phrases. Alright. This is the length. We have the length. Very cool. We do the cosine. Well, also I could do yep. Right now, I shouldn't care about performance. I should care about the behavior. Because if the behavior is incorrect, then all this kind of is for nothing except for fun. Hold on. This needs to be the relative angle. Hmm. Hmm. Do I do A times 2 anywhere? I do. Why do X first here? That's interesting. It's supposed to be the other way around, but whatever. Whatever. Then we do cos times length and times length. And that's what we return. Should work, maybe? Maybe. I feel like I should test this function somehow. It's probably fine. Anyway. Haha. I have one ingredient here now. You can rotate the velocity. Well, wow, I kind of have everything already. And we take, where's our velocity? What angle do we rotate it by? We rotate it by the movement angle. Well, I already have the sin and the cosine, honestly, but I forgot that I cursed myself with that. Oh, I don't keep the move angle in scope, I guess. I just have the sin and the cosine. Let's just pass it directly then, I guess. Do we pass it directly? Do we have the sine and the cosine for the other thing? And here I get the relative angle. Well, hold on. You know, actually, I do want the angle. I don't want the sin and the cosine. Oh, actually, I can just... Well, yeah, it's gonna be kind of the same. Whatever. Who did that? Who did that? That was kind of the same. Same shit. The rotated velocity. And then we have the lenient friction and we have the normal friction. Or we have the aggressive friction rather. And then this is gonna be just this. Friction is not really a thing, we just have that and that. I'm gonna print the lenient friction in here. And then what we're gonna do, I'll take the rotated velocity and we multiply one of the components. Hold on. So let's say this is the direction we want to go. And this is the direction we don't want to go. Lenient friction. Aggressive friction. Yeah. And then we want to do this. Let's look at dish. And we just take the movement angle, I guess. I think. Where do we multiply by speed here? Multiply at the same time as we multiply by the friction values. Okay, so we have that. I do this. Oh, we do have some errors, but that's fine. Oh. Well, added movement. It needs to be using the lenient friction. Let's see. I'm not the most hopeful about this. We'll see if we get launched into the infinity. So we're on ice. But only the direction that... Well... I have no clue what's going on. Why is the friction so low? What? 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 And like the lean-in friction isn't even that low. Why are we doing this? No. No. No, I don't like this. Like here it would kind of make sense because we're going like this. When I'm moving like this, we should slow down more rapidly than when we move like this. Ay, ay, ay. My jumping still gives a small boost, even if we're not holding any inputs, but that's intended. No, do these. I think I just want to print the friction force, honestly. What are we actually doing here? And technically, if we... Hold on, so it's like 0.0 there. And now, okay, this makes sense. This makes sense. This doesn't. Let's flip these. This shouldn't be the answer, but we'll see. If it is, then that's funny. It definitely is not the answer. I have even less friction. Boy, did we just accelerate? Only backwards? I have no idea. Oh, there's definitely angles where you accelerate. Very interesting. So, okay, these were the right way around. There's still something that I'm doing wrong though. Why is the friction force so low? Why is it so low? Yeah, lenience friction is 0.5 now. If it's the earlier math fucking you up, they should fix it. If it's something else, then I'll get to see it right now. Because it is the current math somehow messing me up. For some reason in the air, you get massive movement. As like you have stronger movement if you're going straight rather than if you go in a diagonal. It's like so exaggerated as well. Holy shit. What is going on? What is going on? What is going on? What is going on? Like this shit works. I shouldn't be using the 8 angle. I should be using this, for example. I think this one works. I'm gonna make the rotation a bit faster. So this is just getting the component that's going the direction of the movement. And this is the one that's getting the opposite one. Does it make sense? Yes, it does. Relative angle. Am I getting the relative angle anywhere? I guess I'm doing it in the rotate 2D vector thing. I don't know if this has to be the other way around. Maybe. Maybe. This is definitely peak programming. definitely not correct. It's like so erratic now. There's at least some logic to it before, but now there's... Well, obviously there's logic, but I don't know what it is. I wonder if I need to have these in the same orientation as the other one. Because the other one does the 8-tan like the kind of incorrect way around, I guess. Might be good to have the same here. That feels erratic again. I'm gonna do this. I should make a world with a smaller plane. This is like 5k by 5k. It takes a while to load. Oh shit, look at that. Now it kind of just works. And the lenient friction is 0.5, which is not very lenient. Also, what did the... We still slide very, very slowly here. Takes a while to stop, which is not good. Does it take so long to stop? Also, rotated velocity should already take into account the horizontal speed, right? Yeah. We shouldn't need to do that there anymore. I wonder if that's affected anything. It should have made the friction even more aggressive, if anything. But we'll see what happens. Oh, okay. Now the friction kind of just feels normal. Hmm. And we can reach our normal speed. Now we cannot accelerate with jumping. Still, progress. We're on slide forever for no reason. Let's restore the lenient friction to what it was. And now I can actually build speed. Does it feel correct though? Can go this direction. Yeah. It felt very strange. It's like I'm locked on this axis. Like it doesn't it doesn't want to turn the velocity until we're going slow enough. That's how it feels. Like this autocorrect in the movement. It feels very, very off. And it's probably not tied to axes, so I can do this. Or is it? Is it actually tied to the axes? Go like this kind of an angle. It feels okay there. Go fully diagonal. Did you be like that? There. I have no idea what this math is doing. Like on the world axis, it's behaving differently. Like, it's actually so good when we're moving not on the world axis, I think. Like I can gain speed here. I can go here. I'm going fast. Like, oh, let me turn here. It slows down relatively quickly. But then if we're moving straight, then it wants to slow down before you can turn, which is like, what? Why? Probably the rotation being fucked up. Yep. Oh, that's interesting. Okay. What if we just rotate by the negative move angle there? Hopefully that works. It does not work like that. You gain some speed. Oh, some amount of speed is being gained if we look in, like if we go here and then we look here. Whee! It's not that at least. If I do negative move angle on both, I'm just coping right now. Okay. Feels normal. But still restrains our movement. Wait, the friction is now also more aggressive on the diagonals. I can't gain speed. That's interesting. What is going on? Probably my rotate vector function is incorrect. Or let me cross-reference this. Yeah, I need to rotate by the relative angle, not the absolute angle. That's probably the reason it's feeling like dog shit. Mm-hmm. Right, do we have the velocity angle then? Anywhere? Probably not. I can just get it easily. Go. Do that. Oh. Oh yeah, I did it incorrectly here. There. Let's see now. Just why does it look in certain directions? It just breaks instantly. And it's pretty violently. Does that need to be the other way around, perhaps? Nope. Is it now the case that I can go this direction without issues? There's like no direction that's not broken. That's very interesting. Like running out of ideas of like what to do without having to think this through completely. Yeah. Honestly, I think I'll continue this another time. I am not feeling it. Not feeling it. Not feeling it at all. I do know the logic. I have it in Godot code. I just need to translate some utility functions to the Rust side, and then I can write the same code, but I'm just tired. I need to rest. So yeah. I'm just gonna format the code. It's annoying because I know the logic I want. I just need it in code now. Well, yeah, it's whatever. Let's check. Do we rate? Why not? Oh, that was like hidden beneath this banner. Anyway, yeah. We don't rate. I'm just gonna hop off. Where's the thing? Here's the thing. Chat is supposed to be below. Yes. You can watch stream at nearparty.com/stream. You can find all the VODs, including at nearparty.com/stream/archive. Schedule, it's at nearparty.com/stream/schedule. And the Discord at nearparty.com/stream/discord. And yeah, I'm thinking I'm probably gonna update the, like, I'm gonna put a page on my website soon with information about this game. Once I get the friction to feel nice, I think. Well, let me actually check. I can remove that. I need to also clean up these notes. This is correct. This is like what I need to do is make the friction feel nice, then just make levels basically. And to make levels, I might do a thing where I make some more block materials, like nice looking ones. But once I get the friction, honestly, I think friction, make levels, make a page, and then, you know, make materials, make it look nicer. And I don't, we'll see. But for now, I already did the outro. See you later. Bye bye.